So today's lesson is on quadrilaterals. Inscribed in circles. And we are on page 39?
Yeah.
All right. So before we do anything, what is a quadrilateral?
Four.
A shape or a figure that has four sides. Name a quadrilateral.
Square.
Square. What else?
Rectangle.
Okay.
Parallelogram.
Okay. Rhombus. A hexagon does not have four sides. A trapezoid. Okay, so square, rectangle, parallelogram, trapezoid, rhombus. Anyone? There's one more. Which is a kite.
A rhombus. There's one more.
No.
You said there's one more.
Yeah, kite.
Oh.
Okay, so I want you to start by drawing a circle. Yeah, we're talking about circles. No, it does not need to have to be a big circle. Okay. Now, if a quadrilateral is inscribed in a circle, that means the quadrilateral is in the circle and all of the vertices are on the circle. Okay? So, we have our center.
Should we draw our circle back?
It does not need to be this big, no. We have our center and we're going to draw a quadrilateral. So, it does not have to be perfect. Okay? It has four sides and all of the vertices are on the circle. It does not have to be perfect. Okay? It doesn't have to look exactly like mine. Okay. So our rule is, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. What does supplementary mean?
180.
They equal 180. So what would be opposite angles? Angle what and angle what? Perfect. So angle X plus angle Z will equal 180 degrees. Are there any other opposite angles? Y and W. So angle Y plus angle W will also equal 180 degrees. Okay, that's our rule for today. So we're going to be using information that we already know, plus this information to solve. Can we handle that? Okay. Everyone have this? Yes? Okay. We're going to draw another circle. It does not have to be perfect. My drawings have changed every single class period.
Wait, so if those are supplementary, then never mind.
All right. Now, before we solve, I want to show you the difference in something. So here's my picture for 6th period, right, for you guys. Here was my picture during 1st period. Very different. Now, here's what I want to point out to you. Looking at this picture, what kind of figure does it look like? A rectangle. It looks pretty much like a rectangle. And you know that rectangles have angle measures of 90 degrees, correct?
Yeah.
Now, in geometry, you can never assume something. So unless I actually had a 90-degree angle drawn in for those, you don't know that that's a rectangle, and you don't know that those angles are 90 degrees. Okay, just because it looks like that doesn't mean that's the way it is. I'm an awful drawer. Okay, this is not what it should look like. It should look more like this. Okay, but just know that you can't assume something unless it's actually drawn in for you or the directions say this is a rectangle. Okay? All right. So our rule says that opposite angles are supplementary. What are my opposite angles that I would use? K and D. So 59x minus 2 plus 31x plus 2 equals 180. Combine like terms. 59x plus 31x is 90x. The 2's cancel, leaving me with 180. Divide by 90, x equals 2, which is great. But is that what I was asked for? I have to find LDJ, which is angle D. So 31 times 2 plus 2 is 64 degrees. See, not too bad, right?
Yeah, now you're about to turn.
I'm not.
Throwing something crazy.
Okay, let's try another one.
Easy. Now let's try this one. It's gonna be.
It's gonna be
Can we try another one?
It's gonna be a rhombus in the circle.
It's not. It doesn't matter what shape it is. It's still a parallel or a quadrilateral. Okay, so let's draw another circle.
Something triangle. Yeah, you're gonna throw a triangle.
No, I'm not.
I'm obsessed with this.
Okay, so I would like you to try this one. So the rule says if there are opposite angles, they're supplementary. So you should have the equation. 14x plus 12x minus 2 equals 180. So far, so good? Okay, combine like terms. So 26x minus 2 equals 180. I'm going to add 2 to both sides. And when I divide by 26, I get x equals 7, which is great, but not what I want.
Can we plug it into whichever one? Whatever. Like 14x or.
So this is the one it's asking for.
Oh, yeah, I'm sorry.
It's okay. So technically, if you plug it into this one, what would you do to find this angle? Something extra, so you would subtract it from 180, right? It is extra work, so let's just plug it into what we need, right? So 14 times 7 is 98 degrees. Did you get that? Awesome. Okay. Let's. Oh my gosh, Jordan. No, I'm not. Just,
Yeah, then you're gonna say, okay, what happens if they're not opposite angles?
just draw another circle.
Yeah, that's what you're about to say.
She tries the previous round, but
How many more examples do we have?
5 million.
All right.
What's your favorite number, isn't it?
Mm-hmm.
700. Maybe we can take on my whole page.
I'm sorry, Madison.
It's okay. That wire would be one.
Oh, why?
We're solving for that one, huh?
Oh. Okay, so here's what I want you to do. I want you to talk to the person next to you. It's not that wacky. I want you to talk to the person next to you and come up with a game plan on how to solve it. You have been taught how to solve this problem. Okay? You have. So use all your information that you know about circles and see if you can come up with a game plan. You have to solve for X before you can do anything else. Okay, so take a second and talk to your neighbor. So we have some information, but you will notice that we don't have opposite angles. So we can't set T and R equal to 180 because I don't know what R is, right? But I do know this angle creates this arc. How can I find that arc? Multiply it by 2. This is nothing new. You know this information. So 36x plus 2. Correct? Okay. Now there's something else you should notice about this circle. What else do you notice about this circle? You have all the pieces. So all the pieces of the circle equals 360 degrees. So 37x plus 4 plus 16x minus 2 plus 36x plus 2 equals 360. Combine like terms. 37 plus 16 plus 36 is 89x plus 4 equals 360. If you subtract 360, you get 350, or sorry, if you subtract 4, you get 356. And when you divide by 89, you get x equals 4, which is great. But I'm asked for angle YT, YTS, which is this angle here. So 18 times 4 plus 1 is 73 degrees. See, not too bad? Okay. Last problem. It's not.
Miss Bart, it is.
It's not.
It is.
It's not.
Here comes the star. Here comes the star, yeah. What those stars?
Draw a circle.
Try again.
Shh.
I want pizza really bad.
Did you cheat, Alex? Is that what you said? What is it?
So think about it. Talk to a neighbor.
I got it.
Okay, good. Think about what you know, think about what you can find, and see if you can set up and solve. So you should see your inscribed angle. When we go from angle to arc, we multiply by 2. Okay, so if I multiply by 2, I get 12x minus 14. Okay, that gives me this. So the angle, when multiplied by 2, is going to equal the entire arc. 4x minus 2 plus 7x plus 1. You could have also worked the other direction because our formula says the angle is half of the arc. So I could have plugged in 6x minus 7 equals 1/2 and then still added these together and used the reciprocal, which would have given me the same thing.
With more work.
Yes, I'm just telling you. Okay, combine like terms. So 12x minus 14 equals 11x minus 1. I'm going to subtract 11x. And I'm going to add 14. X equals, you can't see that, x equals 13. Which is great, but not what I want. We need to plug it back into angle HSR. So 6 times 13 minus 7 is 71 degrees.